Today's daily dose of math is about finding the median. The median is the middle value in a set of data, and finding it is a fairly straightforward process, but there can be different steps depending on how the data is given to you. So I have 3 examples here, and I'm going to start with the simplest one. Here we have some data. It's only 6 values, so the sample size is 6. Our n is 6. Using the n plus 1 over 2 formula, therefore, I have 6 plus 1 over 2, which is 7 over 2, and that gives 3.5. When we get this 0.5, it means that the median is the average of the third and fourth data values. The median itself is not 3.5. We have to count to find the median. So we're looking for the third and fourth values. 1, 2, 3, 4. The third and fourth values here are the 14 and the 18. The median is the average of those 2 values. So I do 14 plus 18 over 2, and I get 32 over 2, which is 16. My median in this case is 16. In my second example, I have a frequency table. And we have to be careful because the data is not these numbers here. We don't have a 3 and a 4. The data is over here. And if you read the table carefully, you can see that. What this means is that there are 3 15s and there are 4 16s, etc. So to find my sample size, I just have to add the frequencies, and these numbers add up to 10. So my sample size, my n, is 10. n plus 1 over 2 becomes 10 plus 1 over 2, which is 11 over 2, which is 5.5. Therefore, it's the average of the 5th and 6th values in the data. Starting with the smallest values, the first 3 are 15s, the next 4 are 16s. So both the 5th and 6th values in this data are 16s. I can show my calculation of the average of the 2 middle values, the 2 16s, but it's going to give me 16. My median for this data is 16. Here's another type of frequency table, but this is classed data. And this is a little trickier because we don't know what the data is. We can see that the frequencies add up to 33, so our n is 33. And we start the same as usual. We've used the n plus 1 over 2 formula. So I have 33 plus 1 over 2, which is 34 over 2, which is 17. This time I don't have the 0.5, so my median is the 17th value. But again, I don't know what the values are. So when I find the median for this type of data, all I can do is find an estimate for the median, and to do that, I use this formula. Now this formula looks horrible to a student who hasn't learned it yet, because there are so many variables and they have strange letters being used for them, but this becomes easy like any other formula once you practice it a little bit. You get used to what the variables mean, and you are replacing all of the variables with numbers so that you can simplify and find your median. We need to know that our median is the 17th value because the next step is to figure out which of these classes does the median land in. So what I do is I start counting from the lowest values. From 0 to 10, there are 6 values. We haven't reached our 17th yet. When we add 4 from the second class, we now have a cumulative frequency of 10. And we haven't reached 17th yet. But when we add 14 to the 10, we have now a cumulative frequency of 24 values. We've passed 17. That means our 17th value is one of these. It's one of these 14 values that are somewhere between 20 and 30. Well, we now have narrowed it down. We know our median is somewhere between 20 and 30. This, therefore, is our median class. We have figured out that the 17th value is in this class. That means our median is in this class. We call it the median class. And the good thing about knowing the median class is it tells you very quickly 3 of the 4 values you need to fill in this formula. L sub I is the lower limit of the median class, and that's the 20. F is the frequency of the median class, and that's the 14. W is the width of the median class, which is 10, but of course, all of the classes are 10 in width. All that's left now is the R. At this point, the student is nearly finished, but students find the R the most confusing thing because there are so many steps in this process. The R value, though, is by itself, again, an easy calculation to find. R is equal to this value that we got to when we did the n plus 1 over 2 formula, 17, minus the cumulative frequency of the previous class. So we go from our median class up to the previous one. Its cumulative frequency, remember, was 10. So we do 17 minus 10, and our R is 7. Finally, we have all the information we need, so we can simplify it and find our median. And remember, this is an estimate of the median. Remembering to apply the order of operations, the first thing I'm going to do is this division. 7 divided by 14 is 0.5. Next thing I have to do is this multiplication. 0.5 times 10 is 5. I have 20 plus 5. My median is 25. My estimate for the median of this data is 25. We'll never know what the real median is for sure unless we are provided with a list of these 33 values. But if we had that list of values, we wouldn't have to use this formula. We would be able to list them from smallest to largest and use this method instead. This is my 3 examples of finding the median, depending on the 3 different ways the data could be given to you. And this is today's daily dose of math. Please like this video and subscribe.